Okay, a black hole is a region of space-time um, exhibiting such strong gravitational effects that nothing can escape it. Not even light. And finally, an observer views a distant spacecraft that is 23 kilometers from the center of a black hole. The spacecraft contains a clock that ticks once every second, and the ticks can be detected by the distant observer. In 2 minutes, the observer counts 112 ticks of the clock. Okay, so dilated time here is going to be the longer time. So this is a gravitational time dilation question. So t is going to be equal to 200, and t naught is equal to 112. And we're going to use the equation for gravitational time dilation. I'm just going to quickly grab a data. Okay, so we have that the shift in time, delta t, is equal to this delta t naught over square root of 1 minus rs over r. Okay, and then what we're asked to find is the mass of the black hole. So we need the equation for the short Schwarzschild radius as well, which is rs is equal to 2gm over c squared. Okay, and now we know both delta t. In fact, I'm just going to call these delta t because it's the time between the first tick and the last tick kind of thing. And we know delta t, we know big G obviously, we know c, we know little r. Little r is 23 kilometers. And so we know everything here except for the mass. So we should be able to find the mass. Okay, so what we do is we'll plug in rs in here. And we get delta t is equal to delta t naught over the square root of 1 minus 2gm over rc squared. Now we just want to rearrange for m. So we get delta t naught, delta t naught over delta t, is equal to, in fact, let's just square that as well, is equal to 1 minus 2gm over rc squared. And then it's no big deal getting this. So we then get m is equal to rc squared over 2g times 1 minus delta t naught over delta t all squared. And finally, that will give us an answer for the mass of 2 times 10 to the 30 kgs.